Now that we've defined all of our terms, we are ready for the big definition here. Okay. Theorem. If A is an n by n matrix, then regardless of which row or column of A is chosen, the number obtained by multiplying the entries of that row or column by the corresponding cofactors and adding the result produces products is always the same. Okay, the resulting products. Excuse me. Okay, that sounds completely nonsensical, but this thing is called the cofactor expansion. Okay, when you multiply entries by cofactors and then add up all those products, you always get the same number. And by definition 362, because it's always the same, we're going to call that number the determinant. The determinant of A, and those sums, like I said, are called the cofactor expansions. Now, there's two notations for this. There's DET and there's absolute value. Okay, so we'll use the absolute value bars in here because they are the easiest. But so this is the determinant. Now let me show you what this thing looks like by example. And this is going to look very familiar because you've done this before. Okay, so compute the determinant of the matrix along the first row and first column. Let me do it along the first row first because that will be very familiar to you. So the determinant of A along the first column is going to be, okay, so that's A11 times C11. All right, so we're going to multiply the entry with the cofactor. Then this thing, that's going to be A12, C12. And then this thing, that's going to be A13, C13. Okay, now just hold on to it here. A11 is just the entry 1. C11 is going to be positive, okay, positive in the first spot. Now we're going to erase this row and this column. I'm going to copy down this matrix. That's the cofactor. That's the minor, right? 1, 4, -1, 2. Okay, that's C11. Next, we have the entry A12, which is 2, times, okay, now this cofactor gets a minus sign. So instead of plus, it's actually minus. I'll just put a -1 there. And I'll delete that row and that column and put 3, 4, 5, 2. Is this looking familiar yet? It really should. You saw it in Calc 3. Okay. Next, the A13 entry is 2. It's plus, minus, minus, plus, so it's positive. Now determinant of cofactor, so we're going to ditch that, and I get 3, 1, 5, -1. Okay, very good. Where did you learn this thing from? Well, this is exactly how we did cross products, right? So the cross product is a cofactor expansion where you put I here and J here and K here. I remember it was plus for the first one and then minus for the J and then plus for the K. Like what we were doing this exact thing, right? Not like this thing, it was this thing. Right, and so then this was the I, and this was the J, and this was the K, and so this, you've done this before, okay, but now we have numbers, which quite frankly makes it more annoying than doing cross products. All right, let's go ahead and finish this thing off. So I get 1 times, I'm going to get 2 minus -4, so 2 plus 4, minus 2 times, that's going to be 6 minus 20 plus 2 times -3 minus 5. Forgive me if I'm not doing math right here. 6 minus 2 times -14 plus 2 times -8. 6 plus 28 minus 16, so that's going to be -10. That looks like 18. Hopefully I did that right. Okay, I didn't leave myself a ton of room here. Squeeze that up a little bit. Now let's try the determinant of A with the cofactor expansion along the first column here. All right, so determinant of A is going to be 1. Okay, so 1 there, ditch that, and I get 1, 4, -1, 2. Okay. Now going along the first column here, so it's going to be -3 times, and we're going to ditch this and ditch this. So I have 2, 2, -1, 2, plus 5 times, ditch this, 2, 2, 1, 4. Okay, so that gives me, all right, this first one I already did up here, so that's going to be, that's just 6 for that one. -3 times, it's going to be 4 plus 2, plus 5 times 8 minus 2. Let's hope this works out better here. All right, 6 minus 3 times 6 is -18, plus 5 times 6 is 30. All right. 30 minus 18 is 12. 12 plus 6 is 18. Woohoo! We got the same thing. Very good. So those are two different cofactor expansions, and we could do it how many different ways? Maybe a good question. How many different ways can you do a cofactor expansion? Well, I have 1, 2, 3, 1, 2, 3. So there are 6 ways. It'd be a good question to ask yourself. How many different cofactor expansions are there in an n by n matrix? And now maybe you're wondering, like, what happens in a bigger matrix? This was all fine and good because every single time I had a submatrix, I had a 2 by 2 in which I knew how to do the determinant from a formula. What if this was a 4 by 4 and the determinant of the submatrix was a 3 by 3? Well, if you're asking yourself that, then you understand the gravity of the situation, because each one of those 3 by 3s is going to involve this calculation right here. So if you've got a 4 by 4, then this process is going to be the process you do for the first determinant in the first cofactor expansion. You'll have 4 of these to do. These sort of get big in a hurry. So speaking of 4 by 4, let's do one. Here's a 4 by 4 matrix. Let's calculate the determinant. Okay, now again, if I'm just going to do the cofactor expansion along the first column here, it would be that with this determinant. Okay, then it's going to be that with this determinant. Okay, and then it will be 5 with that remaining determinant. Yeah, okay, so that's yuck. I don't want to do that because every single one of those determinants is a 3 by 3, in which I'm going to have to do another cofactor expansion for. So let's work smart here. Zeros are your friend, right? So in this first one, if I go along the first column, it's going to be 1 times a determinant plus 0 times a determinant that I won't have to do because it's 0, plus 0 times a determinant times 1 I want to do, and then 3. So along that first column, I'll have to do 2 3 by 3 determinants. That's a help, but maybe there's a better one. So how about we choose this column, because in that column, I'm only going to have to do 1 subdeterminant, okay? Only 1 minor calculation. Okay, so let's do the cofactor expansion along that row. So determinant of A is going to be, okay, so 0 plus 4 times, now what is the determinant remaining? 103, 5, -3, 4, 2, 0, -2. Okay, so that's this entry for my cofactor expansion, and then I'll have these two, which are going to be plus 0, plus 0. Okay, so those all go away. It's probably a bad thing to do in a lecture, but you get the idea. All right, now I have to do a cofactor expansion again. So 4, Can you see a good one to go with? And, you know, with 3x3s, I would say that if you're comfortable doing cross products, there's nothing wrong with just always going across the first row. Okay, you might occasionally get some yuckier calculations, but in this case, there's nothing wrong with that. They're fairly short. But there is an easier way. Let's find the easier way, which is to do the middle column, because again, you can see that there are two zeros here. Zeros are your friend with determinant because they kill off the determinants, right? Okay, so, oh, I think I missed something before. So we need the cofactor expansion. So plus, minus, plus, minus. So this should be -4. I'll make sure we tack that on. So -4. Okay. Now in this one, it's going to be plus, minus, plus. Okay, so -4 for the first one, and then -3 for the second. Subdeterminant, if we ditch that, we get 1, 3 to -2. And now we are down to just formulas. So here we go. -4 times -3, and then -2 minus 6. So the whole thing is going to be 12 times -8. What is that? 12, 60, 72. I'm going to cheat. 12 times 8. 96. Whoops, -96. Cool. All right, so you can see that if you choose wisely, then this whole process can be made much, much better. Okay, now moving forward, we're going to have to do determinants. Now, truth be told, you absolutely can, calculators do these, okay? I'm not even going to show you, you can find it on your calculator. A calculator will absolutely do this determinant without any problem at all and in a much faster time, okay? Should you sort of do some of them to develop a sense for how they work? And the answer is yes, because we're going to run into some where we can't just use our calculator, and this is what we're going to need them for later on, is we're going to need them to do determinants like this, okay? So let's find the determinant of this matrix that has variables in it that if you're working with a TI-83, it's not going to do it. So how do we find a determinant like this? Well, same deal, it's a 2x2, so it's just going to be x minus 1 times x minus 2 minus 3 times 4, 4 times 3 times 4. And so there's the determinant. And now let's simplify this thing. So that's going to be x squared minus 1x minus 2x is minus 3x plus 2 minus 12 is x squared minus 3x minus 10. Now here's what we're actually going to want to do. We're going to want to figure out when that determinant is equal to 0. And so you put some directions here, solve. If I want to solve determinant of a equals 0, then I'm just going to take all of this stuff from the first part and just say that this makes x squared minus 3x minus 10 equal to 0. And we're going to be very interested in figuring out what makes determinants 0. So we'll have to do some factoring. X minus 5, x plus 2 equals 0. So the values x equals 5 and -2 are the values of x that make a have determinant 0. Okay, so those are going to be the things that we are interested in a couple chapters. Okay, so we'll definitely come back to this notion here, but this is why it's important for us to develop some sort of sense of how determinants work, is because we're going to be doing a lot of this, and so kind of developing a number sense, so to speak, about determinants is very helpful. Okay, now there are a lot of properties of determinants that we need to talk about, but we'll do that in the next video. I'll see you then.